Hello everyone, welcome back to our channel Problematical. Today we'll be discussing exercise 12.2. The first question is find the distance between the following pairs of points. Now to find the distance in this case we require a distance formula. Distance formula is PQ is equals to root of, PQ is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Here, the given points, let these points be A and B, P and Q. These points are P and Q, 2, 3, and 5. And Q is equals to 4, 3, and 1. In a general sense, your P should be x1, y1, z1, and Q is equals to x2, y2, z2. So, here you can equate these two. x1 will be 2, y1 is 3, z1 is 5, x2 is 4, y2 is 3, z2 is 5. All you have to do is place these values in this formula. So, your x2 is 4 minus 2 whole square plus 3 minus 3 whole square plus 1 minus 5 whole square. This should give you root of 4 minus 2, 2 square plus 0 square plus minus 4 square. This is equals to 4 plus 0 plus 16, which is root 20. It can be written as 2 root 5. This is PQ for the first section. Second value. You have to find the distance between these. Now your P value is minus 3, 7, 2, and Q value is 2, 4, minus 1. Therefore, the PQ will be equivalent to, I'm not writing the formula again, which is x2 minus x1. So I'll directly place the values of x1, x2, y1, y2, and z1, z2 in the formula. This formula, equation 1. I've taken the formula from equation 1. So here your x1, x2, x1, y1, z1, x2, y2, z2. You have 2 minus of minus 3 whole square plus 4 minus 7 whole square plus minus 1 minus 2 whole square. This is equals to root of 2 plus 3, that is 5, 5 square 25, plus 4 minus 7 is minus 3 square 9, minus 1 minus 2 minus 3 square 9. So 25 plus 9 plus 9, which will give you root of 48. 43. PQ is equals to 43 for your second situation. In your third situation, the P value is equals to minus 1, 3, minus 4, and Q is equals to 1, minus 3, 4. Therefore, your PQ will be equivalent to root of 1 minus of minus 1 whole square plus minus 3 whole square plus 4 minus of minus 4 whole square. This is equals to 1 plus 1, that is 2 square 4 plus minus 3 minus 6 whole square is 6 square, which is 36 plus 4 minus of minus 4 minus of minus 4 is 4 plus 4, which is 8. 8 square is 64. So this is equals to root of, you can add them, 104. 4 into 26, so 2 root 26. This is your PQ value for the third part. Fourth part, P is equals to 2 minus 1, 3, and Q is equals to minus 2, 1, 3. Now here your PQ is equals to root of minus 2 x2 minus x1 whole square plus 1 minus of minus 1 whole square plus 3 minus 3 whole square. This is equals to minus 4 square, which is 16. 1 plus 1, 2 square, 4 plus 0. This is equals to root of 20, and 20 is 4 into 5 to root 5. Next, show that the points, the three points are collinear. Collinearity can be shown either by section formula or distance formula. In this exercise, we'll do it by distance formula. Next exercise, maybe by section formula. Now, to show that 3 points are collinear, we know that collinear means all 3 points should lie on the same line. If you have 3 points, say A, B, and C, and they are lying on the same line or a line segment, then they are said to be collinear in nature. That means one and only one line passes through 3 distinct points in a plane, meaning of collinear. So what we'll assume is, for the time being, we'll assume these 3 points not to be collinear, and we'll find the distances between them. So we'll assume this is your point A, minus 2, 3, 5. Then you have another point B, 1, 2, and 3. And C, 7, 0, minus 1. AB distance will be equivalent to root of 1 minus of minus 2, which is 1 plus 2, 3, 3 square, plus 2 minus 3, which is minus 1 whole square, plus 3 minus 5, which is minus 2 whole square. This is equivalent to root of 9 plus 1 plus 4, which is root 14. BC is equals to, again, root of BC is equals to 7 minus 1 whole square plus 0 minus 2 whole square plus minus 1 minus 3 whole square. Never try to solve directly. Never try to reach the second stage directly by observation. Always try to write this first. This will avoid any confusion in your writing or in your verification. It will also help you with your verification. So 7 minus 1 is 6. 6 square is 36 plus 0 minus 2 is minus 2. Minus 2 square is 4 plus minus 1 minus 3 is minus 4. Minus 4 square 16. This is equals to root of 56, which is 2 root 14. AC. Now AC is equals to C minus A, which is 7 minus minus 2 whole square plus 0 minus 3 whole square plus minus 1 minus 5 whole square. This is equals to root of 9 square 81 plus 3 square 9 plus minus 1 minus 5 minus 6 square is 36. This is equals to 90 plus 36 root of 126. Now 126 you can split it into, it's divisible by 2. 2 into 63. 63 is 7 into 9. So you have 2 into 7 into 9. 9 can be taken outside. So this is 3 root 14. Now, if you can observe, if we draw these points over here, if I call this point as A, the distance from A to B is root 14. There's a distance from A to B, which is root 14. There's a distance from A to C, which is 3 root 14. So if this is root 14, this is root 14, then there's a distance from A to C, which is 3 root 14. At the same time, BC is 2 root 14. Why I was able to draw this on the same line? Because AB plus BC will give you AC. By observation, by observing these points, we came to a conclusion that AB plus BC is giving you AC. Since this is true, or you can even solve it, AB plus BC, we'll calculate it, root 14 plus 2 root 14, and this will give you 3 root 14, and 3 root 14 is equivalent to AC. So since AB plus BC is equals to AC, we can say that A, B, and C are collinear. Next, verify the following. These 3 points are vertices of isosceles triangle in the first part. Now, isosceles triangle means a triangle in which 2 sides are equal. The measure of 2 sides are equal. So if we have an isosceles triangle ABC over here, then at least 2 sides should be equal. The third side may or may not be equal to these 2 sides. If it is equal to these 2 sides, it becomes an equilateral triangle in which all sides are equal, and thereby all angles are equal to 60 degrees. Here in isosceles triangle, your base angles are equal because sides opposite to these base angles are equal. So with this information, all you have to do is find out the distances AB, AC, and BC. If any 2 sides measure are equal, then the triangle is an isosceles triangle. Let's try to calculate these measure of lengths. Let these be points. A is 0, 7, minus 10. B is 1, 6, minus 6. C is 4, 9, minus 6. If you calculate AB, it will be equivalent to root of x2 minus x1 whole square, which is 1 minus 0. And in every question, you're supposed to mention the formula at every stage. I'm not mentioning it, but you should mention it. 6 minus 7 is minus 1. Let's write them. 6 minus 7 whole square plus minus 6 minus of minus 10 whole square. This is equivalent to root of 1 minus 0 whole square, 1 square, plus 6 minus 7 whole square, minus 1 whole square, plus 6 minus of minus 10 is 6 minus 6 plus 10, which is 10 minus 6, which is 4 square. This is equals to root of 1 plus 1 plus 16. Root 18. 18 is 3 root 2. Next, BC. BC is equals to root of 4 minus 1 whole square plus 9 minus 6 whole square plus minus 6 minus of minus 6 whole square. This is root of 4 minus 1 is 3 square plus 9 minus 6 is again 3 square plus minus 6 minus minus plus 6. So minus 6 plus 6 will give you 0. So 3 square plus 3 square, 2 into 3 square, which is 18. Again, 18 can be written as 3 root 2. So by default, we found out that AB is equals to BC. We still have to calculate AC. AC is equals to root of 4 minus 0 whole square plus 9 minus 7 whole square plus minus 6 minus of minus 10 whole square. This is equals to root of 4 square 16 plus 9 minus 7 2 square, which is 4, plus minus 6 plus 10 is 10 minus 6, which is 4 square. It is 16. 16 plus 16, 32. 32 plus 6, 36. 36 root of 36 will give you 6 AC. For all practical purposes, all distances are calculated as positive. We are not considering negative distances over here. That's why even if you're taking square root of certain numbers, you'll always end up with a positive value at the end. So here AB is equals to BC. Therefore, triangle ABC is an isosceles triangle. Next you have 0, 7, 10, minus 1, 6, 6, and so only the symbols are varying. And now you are supposed to verify whether these are vertices of a right angled triangle or not. Now, when you draw a right angled triangle, You're supposed to have one angle is 90 degree. This is your 90 degree. If this is your E, let's not call it ABC. This is your PQR. So here you can prove that this is 90 degree only by Pythagoras theorem, which is PQ square plus QR square is equals to PR square over here, which means those two sides which have a 90 degree angle between them, or the variable which is common in these two values, will have a 90 degree angle over here. This is by observation. So let's calculate the distances of the 3 points. We are calling these points as ABC over here rather than PQR. This is just for understanding or explanation. The given points are, we are assuming them as A, 0, 7, 10, B, -1, 6, 6, C, -4, 9, 6. So AB is equals to root of -1 minus 0 is -1 whole square, plus 6 minus 7 is -1 whole square, plus 6 minus 10 is -4 whole square. This is root of 1 square plus 1 square plus 16. This is root 18. This is 3 root 2. BC is equals to -4 minus 1. -4 minus of -1 whole square plus 9 minus 6 whole square plus 6 minus 6 whole square. This is equals to root of -4 plus 1, which is -3 whole square plus 3 square plus 0 square. This is equals to root of 9 plus 9, which is equals to root of 18, 3 root 2. One second. Okay. Next, AC. AC is equals to root of -4 minus 0 whole square plus 9 minus 7 whole square plus 6 minus 10 whole square. This is equals to root of 16 plus 2 square 4 plus 4 square 16, which is equals to root 36. This is equals to 6. Now, your AB is equals to 3 root 2. So AB square will be equal to 18. BC square will be equal to 18. And AC square will be equal to 36. By observation, we can say that adding these two values will give you AC square. So AB square plus BC square is equals to 18 plus 18 is equals to 36. This is equals to AC square. Therefore, we can say that triangle ABC is a right angle triangle is a right angle triangle 90 degree at AB plus BC. The B is common over here. Right angle at point B. Next, in the third part, you're asked to prove whether the given points are vertices of a parallelogram or not. So there are 4 points mentioned. Let's name them. A, -1, 2, 1. B, 1, -2, 5. C, 4, -7, 8. And D, 2, -3, 4. So 4 points are mentioned. If you draw a parallelogram separately, then you can mention these in the cyclic order. Whatever order is the question given you into, the same order is to be considered in a cyclic pattern while drawing the parallelogram or whatever figure is given. So ABCD is mentioned. you'll use the same order in clockwise or anti-clockwise. Now, in a parallelogram, we know that opposite sides are parallel and equal, which means your AB should be equal to DC and AD should be equal to BC. But adjacent sides are not equal. Like it can be called as a parallelogram, but the specific property says that a parallelogram, any figure will be a parallelogram if the opposite sides are equal. The adjacent may or may not be equal. Another property of it is your diagonals, they bisect each other. So say I draw the diagonals, definitely you'll have a smaller diagonal and a bigger diagonal. These diagonals should bisect each other. This is a minimum property. This distance should be equal to this distance, and this distance should be equal to this distance. If this is your point P is equidistant, or P point divides AC into two parts. The P point, the same P point with the same coordinates, will also divide BD into two equal parts. So you can prove that this is a parallelogram either by proving that opposite sides are equal or by using this particular point. So we'll use section formula by proving that it is a parallelogram through point P, but here we will use distance formula. We will find the distances AB, BC, CD, and DA and prove that opposite distances are equal numerically because the coordinates are given to us. Let's calculate. AB is equals to, again, you'll have to write the formula first, then place its value 1 minus of minus 1 whole square plus minus 2 whole square plus 5 minus 1 whole square. This is equals to root of 1 minus of minus 1 is 2 square plus minus 2 whole square is minus 4 square, which is plus 4 minus 1, 5 minus 1 is 4 square. This is equals to root of 2 square 4. 4 square plus 4 square is twice of 4 square. So 4 plus 16 plus 16, 16 plus 16, 32 plus 4, 36, root 36, which is equals to 6. So AB is equals to 6 units. It's not mentioned that it's centimeter or meter, so we'll use the word units. BC is equals to root of 4 minus 1 whole square plus minus 7 minus of minus 2 whole square plus 8 minus 5 whole square. This is equals to root of 4 minus 1 square is 9, 3 square, minus 7 plus 2, which is minus 5 whole square, which is 25, plus 8 minus 5 is 3, 3 square 9, 9 plus 9, 18, 18 plus 25, 43. CD is equals to root of 2 minus 4 whole square plus minus 3 minus 7 minus 3 minus of minus 7, so minus 3 plus 7 whole square, 4 minus 8 whole square. This is equals to root of 2 minus 4 whole square is minus 2 square, which is 4, plus minus 3 plus 7 is 4 square, which is 16, plus 4 minus 8 is 4 square, which is 16. Again, it is root 36, which is 6. AD is equals to D minus A, so 2 minus of minus 1 whole square plus minus 3 minus 2 whole square plus 4 minus 1 whole square. This is equal to root of 2 minus of minus 1, which is 3 square, 9, plus minus 3 minus 2 minus 5, which is 25, plus 4 minus 1 is 3 square, 9. This is equivalent to root 43. By observation, we can say that AB is equals to BC, is equals to, CD is equals to 6 units, and BC is equals to AD is equals to root 43 units. So, therefore, we can say that, which implies ABCD is a parallelogram. The given coordinates are always taken in order, either clockwise or anti-clockwise. Next, find the equation of set of points which are equidistant from these points. Now, set of points which are equidistant from these points. So, if you consider a line, and if you consider these given points as your endpoints, then there would be at least one such point on this line which would be equidistant from these points. Let these points be A and B, and let this point be P. Now the general coordinate of these points will be x, y, z. Apart from P, line just above point P and below point P, you can still draw two such lines over here. This is for understanding purposes. Let us call these points as P1 and P2. So this point P1 is also equidistant from A and B. That means P1A is equals to P2B, P1B, P2A is equals to P2B. So there can be infinite points which are lying on this line which is passing through point P and passing through P1 and P2. There would be infinite lines, and every point lying on this line will be equidistant from A and B. So another way of saying the same thing is the locus. Locus means set of points. The locus of all the points equidistant from A and B is a line, is forming a figure which is called a line. You have to find the equation of the set of points. We know that the locus is a line, or the set of points is forming a line. However, we will consider this as x, y, and z. When you're supposed to find the equation, your equation should be in terms of the set of points. I have represented the set of points in general as x, y, z coordinates. So the equation so formed will be having x, y, z as the variables in it. Now, how can we achieve such a goal? How can we get this equation? By using the condition. The condition is these points are equidistant from the points A and B. So let's consider point P with a generalized value x, y, z. It's given that P is equidistant from A and B, which means PA is equals to PB. This is P being equidistant from A and B. This means PA square will be equal to PB square. Now PA is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now if you take the square, you're getting rid of the root part. So you're left with px minus 1 whole square plus pa y minus y minus 2 whole square plus z minus 3 whole square is equals to p from b, x minus 3 whole square plus y minus 2 whole square plus z minus 1 whole square. Expanding this, x square minus 2x plus 1 plus y square minus 4x plus 4 plus y square plus z square minus 6z plus 9 is equals to x square minus 6x plus 9 plus y square minus 4y plus 4 plus z square minus 2z plus 1. So x square gets cancelled, y square gets cancelled with y square, your 1 gets cancelled with 1, 4x I've written should be 4y. Yeah, minus 4y cancelled with minus 4y, 4 gets cancelled with 4, 9 gets cancelled with 9, z square gets cancelled with z square. What are you left with? On the left hand side, you have minus 2x, then minus 6z is equals to minus 6x minus 2z. Transporting everything on the left hand side, you have 6x minus 2x minus 6z plus 2z is equals to 0. So you have 4x minus 4z. Okay, hold on. Have I made any mistake? Minus, 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 and minus. Yeah, this is positive, plus 2 6x plus 6x minus 2x minus 6z, and this is minus 2z. Yeah, when it will go on the left hand side, it will be positive. Here, z minus of minus 1 would be z plus 1, which will make this as plus, which means this is positive and this is negative, right? Which means here the value will be minus 8z is equals to 0. So 4 in common, x minus 2z is equals to 0, which means x minus 2z is equals to 0. 4 will be divided over here. This would be the equation. This is in terms of x, y, and z. Now the y variable is absent over here because it gets cancelled, minus 4y and minus 4y on both sides for these 2 points, but that's fine. It should be in terms of only these variables. There shouldn't be any other variables apart from x, y, and z. Absence of variables is acceptable, provided it has been initially included in the calculation. Next, find the equation of set of points P. The sum of whose distances from A and B is equal to 10. Now it's a simple equation, simple condition. Equation of set of points P. So P can be considered as x, y, z. You have to consider the equation of set of points P. That means your equation is in terms of x, y, and z. That is what you understand from find the equation of set of points P. The sum of whose distances from A, B, and C. Now sum of distances of this point P. So PA, sum of distances, so PA plus PB is equal to 10. So all you've done is convert words into equations. So this is what you have. PA plus PB is equals to 10. Now PA will be root of A point is 4, 0, 0. B point is minus 4, 0, 0. PA will be x minus 4 whole square plus y minus 0 whole square plus z minus 0 whole square plus PB root of x minus of minus 4 means x plus 4 whole square plus y minus 0 whole square plus z minus 0 whole square. Is equals to, you're taking this term on the right hand side, you have 10 minus root of x plus 4 whole square plus y square plus z square. Now I would have made different changes in this statement itself, but then that wouldn't give you a better picture as to why I'm doing what I'm doing. So I've calculated it first and then we'll make the changes. Now you'll take square on both sides because we want to get rid of this root part. It's very difficult to deal with. Squaring both sides. This gives you x minus 4 whole square plus y square plus z square is equals to a minus b whole square, which means a square minus 2 times a into b plus b square, which is x plus 4 whole square plus y square plus z square. Now you have expanding this x square minus 8x plus 16 plus y square plus z square is equals to x square, which is 10 square, which is your 100 minus 20 root of this value as it is. We cannot do anything in the root. However, we can expand the root, but that will only lead you to writing 2 extra terms for the time being that you will not be able to calculate. This is expanding x square plus 4 into 2, 8x plus 16 is equals plus y square plus z square. So z square, y square, x square, 16 gets cancelled with 16. Now you're left with, what I'm doing is I'm taking this term on the left hand side and I'm taking minus 8x on the right hand side because you have a minus sign over here, it will be plus. So 20 root of this value, which is x plus 4 whole square plus y square plus z square is equals to 100 as it is plus 8x, anything which is on the right hand side, and then transporting this minus 8x over here plus 8x. So your right hand side will be 100 plus 16x. Here you can take 4 common. You'll be left with 25 plus 4x. Okay, so now 20 root of x plus 4 whole square plus y square plus z square is equals to 4, 25 plus 4x, 4 into 5. Okay, now 5 root of x plus 4 whole square plus y square plus z square is equals to 25 plus 4x. 25 plus 4x. Now you can square both sides. Squaring both sides. This is 5 square 25 into this one square is x plus 4. We'll get rid of the root plus y square plus z square is equals to 25 plus 4x whole square. Now if you expand this, it should be 625 plus 4 into 25 is 100, 100 into 2 is 200, 200 into x plus 4 4s are 16x square. Okay. Now what do you have in the left hand side? You'll have to expand this x plus 4 whole square, and I'm multiplying it with 25 as well. So your left hand side becomes 25 into x square is 25x square plus 25 into 8x. 8 into 25 would be 400. 4 into 25 is 100, so it will be 200, sorry. 200 x plus 4 square is 16. 16 into 25. 16 into 25 will give you to 400. See, this you have to calculate. 16 can be written as 4 into 4. 4 into 25. 4 into 25 is 100 into 4, which is 400. Always try and reduce your calculation as much as possible, and always try to do the calculation in mind rather than doing it on paper. That will save your time. Plus 25y square plus 25z square is equals to 625 plus 200x plus 16x square. Now this 200x will get cancelled with 200x, and taking everything on the left hand side, you have 25x square minus 16x square, 25x square from here, 16 over here, plus I'm writing variables first, 25y square plus 25z square, then 400, which is your left hand side term, and then minus 625 from your right hand side is equals to 0. Only these are like terms, so you'll have to calculate this. This is 9x square plus 25y square plus 25z square is equals to minus 225 is equals to 0. You can even take 225 on the right hand side, but beyond this point, whenever we'll write the equation, specifically in 3-dimensional geometry, we'll always try to include everything on one side and equate it with 0. So that concludes the second exercise, 12.2 from 12th chapter. Thank you.